Hi, this is David Davis, and I'm honored to be here with Mr. Kevin Wagner, Vice President of Marketing of Diablo Technologies. How you doing?
Very good. Thank you.
Well, we've been talking about your exciting new memory channel storage here.
Yes.
And I mean, I'm holding 400 gigabytes in my hand. We talked a little bit about the history of the company, where you all came from, what it took to create this new product. Why don't you tell me about some of the use cases?
Okay. So one of the things that's interesting about this is that there are a broad range of applications that can make use of this. There are a lot of different solutions out there that are used for different problems that they're trying to solve in the enterprise. And so in some cases they may use SATA SSDs, they may use SAS SSDs, PCIe SSDs. But right now, enterprises tend to use a different type of solution depending on what problem they're trying to solve, right? And so what you see in a typical data center these days is lots of spinning disks, a lot of SAS SSDs, SATA SSDs. You see a mixture of a lot of different solutions trying to solve many different problems.
Right.
So one of the things very unique about this is that we see that this can really solve a lot of different problems with one solution. And that's really because this is a very modular, very flexible and scalable architecture. And so you can put 2 of these into a system to solve one problem, 4 in another, 8, and scale it to whatever workload you need. Okay. So as far as use cases, let's start with the most obvious one. This is very low latency at very, very high transaction rates. And so electronic trading or high frequency trading, algorithmic trading, call it what you like, very good use case there. Obviously the low latencies is very critical to them, but they also want very high transaction rates, very high throughput. And to be able to log all of those transactions, and in a lot of cases be able to play those transactions back. And so, so we're seeing very good use cases there, and a lot of interest from the traders with this.
So with them, I mean, with those types of companies, even just a little bit of latency or latency that's not consistent, inconsistent latency can cost them perhaps millions of dollars, right?
Yeah, that's actually a very, very good point. So one of the interesting things about this also is the predictable latency, the deterministic quality of the latency. With other solutions, what you end up with is you might be able to get low latency, for a while, but along the way you'll have jitters and you'll have latency that spikes, up to say a millisecond or even beyond a millisecond. And when you have those spikes, that's very, very bad for the traders. Of course, they want it very low and they want it very consistent. So not only is this lower latency than other solutions that are out there, but it's very, very deterministic quality to that latency.
Okay, that's important.
And so it stays very flat.
Yeah.
Absolutely. Yeah.
Okay. So what about other use cases? A use case that's very near and dear to my heart, is virtualization. I've been looking at a lot of ways that virtualization admins are trying to deal with the the IO blender effect and really just the increased consolidation and new applications like VDI. And they've got a lot of IO contention. They need more IO throughput. They've been looking at Flash to help them do that. There's server-side caching. There's hybrid arrays. They're all Flash arrays. A lot of different options. How could Diablo Technologies help them solve those?
So this actually is a good solution for basically everything that you mentioned. This is very good for caching solutions. When you have the IO blender effect, you have a VDI type of environment, particularly when you have a boot storm going on. This will really help in that kind of a situation. Another one is vSAN. So this is working very well with vSAN right now, and we have a lot of efforts ongoing right now to make sure that it works well in a vSAN type of environment.
Nice. I mean, because I recently installed vSAN in my lab, and first I had to buy some SSDs because my server didn't have it, and then I had to buy disk trays to fit those SSDs into my servers, and luckily I had some slots to put those disks in, but not all servers would, and so you guys have really solved that by being able to use the memory bus to add Flash.
Yeah, so this goes into the memory bus of the system and attaches directly to the memory controllers, right? And so so you really end up with a good persistence layer within the memory subsystem. And so so you have DRAM, and imagine if you could take the DRAM in the system and make it persistent. But not just persistent at very small capacities, but persistent at very high capacities. These are 200 gig and 400 gigabyte modules. And so we're not talking about an 8 gigabyte DRAM module that you can then persist in particular cases. We're talking about something that always persisted, And we're talking about 200 gig and 400 gig, and being able to scale these.
Yeah.
So if you take 400 gig modules and you put 8 of these into a system, you're going to end up with 3.2 terabytes of persistent memory.
Wow,
Yeah.
it's incredible. So besides virtualization, tell me what other use cases might these help in?
Okay, so another big area for us is database. Of course, database, typically is, it's another workload where you see a lot of mixed workloads. You see a lot of logging. You see the use of temp DBs, and this works very, very well there. This is very good for a mixed workload, particularly because these modules all work independently of each other, right? DRAM in a system all works independently of each other, and they're all connected in parallel. So while some are being read from, others can be written to, and that's what really makes it so scalable. So for a mixed workload, it ends up doing very, very well.
Okay, fascinating. So we said high frequency trading, virtualization, database.
Yeah.
What else?
So another one is think in-memory database.
Okay.
Something where you're trying to fit everything into the DRAM of a system. In a case like that, we can really augment the DRAM in a system with this device. And people tend to think of flash as as storage, and it is storage. But in this case, this is going to augment the DRAM in the system. The reason being that right now what happens is if the operating system is looking for data and it's not in DRAM, it has to do a page out to go find that page somewhere in storage, out on a PCIe device, out on some storage subsystem, and bring that into memory. And so that page swap that happens has been very costly in the past. And that page swap has kind of been a dirty word for a long time now, right?
Yeah.
And you want to avoid that at all costs. In this case, you don't want to avoid that. In this case, it's very, very different for us. What you want to do is be able to store everything you want, in memory and on these devices. If a page swap happens, then it simply takes the page off of this device, moves it through the memory controller and into the DRAM. So no costly trips out to external storage somewhere. And so essentially you can think of it as a mem copy within the memory controller. So you can imagine how fast that would be to be able to handle a page swap in the system and service that.
So you finally made paging a good thing, or at least not so bad of a thing, and that would allow us to really overcommit our servers even more and maximize that return on the investment for that hardware.
Yeah, from that perspective, I think it actually is a good thing, because what you can do then is you have a very good way of consolidating and still getting a great performance, because you've really expanded that memory footprint inside the system.
Fascinating. Yeah. Well, amazing and really innovative stuff from Diablo Technologies. What's your website if people want to go and learn more?
www.diablo-technologies.com.
All right. Well, thanks so much, Kevin.
All right, thank you.